Okay, today we're going to talk about the last way that we need to be able to calculate moles, the last situation that we will find moles in for chemistry. This is setting us up for stoichiometry when we come back from spring break. You will soon learn that the heart of stoichiometry is the mole, and you need to be able to convert moles from all kinds of different things that you encounter in chemistry. So, last thing that we're going to talk about today are solutions. And I'm sure that you have heard of solutions before. You guys know what a solution is, right? The reason solutions are so important to all of this is that there are a lot of compounds, especially ionic compounds, that can't react unless they're dissolved in solution. A solid ionic compound, the positive and the negative ion are attracted to each other. They're not going to interact with any other ions. So we drop them into water, and then that causes the ions to separate so that we have positive ions and negative ions floating around, and they're available to interact with other substances. What you need to understand about solutions are a couple of words. First of all, the solute, that's the solid, and that's what we're concerned about in the chemical reaction. So, in the solution, you have something dissolved into something else, right? The solute is the solid that's dissolved into the solvent. And the solvent, as far as we're concerned, is going to be water. And we aren't worried about the water. The water doesn't matter to us. What we are worried about is this amount, right? So this is the amount of solute. This is what we need to worry about. This is what we are going to calculate. So this is what we are calculating. Now, the water we do worry about in terms of the total volume when we have the solution. So this here is our solution, and we are worried about the total volume of that particular solution. So we're going to be talking about another form of volume. We were talking about volume with gases. Now we're going to be talking about volumes with solutions. Okay. So when we describe a solution, what we want to do is describe what is in the solute or in the solution, I'm sorry. So specifically how much solute is present. That's what we're worried about. And that's what needs to be in moles. Now, there are several ways to describe solution. For example, there's something called percent solution. We're not worried about that. It's measured in grams. And there's also something called molality, which possibly we will get to towards the end of the semester when we talk about more solutions in general. But what we are worried about and what I want you to know about today is something called molarity. Okay, so molarity, first of all, is represented with a capital M. And what molarity tells us is the number of moles of solute per liter of solution. So this is something that you will definitely want to write down. Molarity is equal to the moles of solute divided by the liters of solution. And just to clarify, I do this all the time. I write solution like in shorthand like that, so you'll kind of know where that's coming from. So molarity is equal to the moles of solute per liters of solution. Now that's kind of wordy, right? We don't necessarily want to write that down all the way every time we're going to solve these problems. So I'm going to show you how we can represent it in a much faster shorthand version. So again, remember that molarity is equal to the moles of solute per liter of solution. And so what we can do is say that molarity is equal to the moles over the volume. As long as we remember that the volume is the liters of the solution, we can use this equation here, okay? Now, again, what we are concerned about are the moles, right? And we also might be concerned about the volume of the solution. So what I want to do is I want to take this particular equation and I want to rewrite it in the ways that we would need to manipulate it. Just like we did for the ideal gas law, we wrote it how we would solve for moles. We also wrote it how we would solve for volume. So we're going to do the same thing. So I'm going to rewrite this equation solving for moles. So if you are trying to find moles, That would mean that you know your molarity and you know your volume. So the equation would be this: moles is equal to the molarity times the volume. And again, remember that that volume that I'm talking about, right, is the liters of solution. Okay. The other thing I want to remind you of about moles is that you can also have grams and convert that to grams. So moles can be converted to grams. Can be converted to grams, right? Or if you're given grams, you can convert it to moles. All right. So we need to know this equation here: moles is equal to molarity times volume. Okay, where the moles can be converted to grams if it's necessary. And again, the V is equal to the volume, which is liters in solutions. Or let's say that you know the molarity, you know the concentration of your solution, and you know how many moles you need for a chemical reaction. You can calculate the volume of that solution that you need to go get off the shelf. So to find volume, we're going to take that same equation, but we're going to manipulate it a little bit differently. This is kind of the tricky algebra, right? We have to swing the volume to the other side and then divide to get it by itself. So to find volume, V, right, what we're going to do is we're going to take our moles and we're going to divide it by the molarity. Okay? So those are our two equations that we need to be familiar with: to find volume and to find moles. And as long as we know those two equations come from molarity, we can then solve any kind of a problem for solution. So let's take a look at a couple of examples. I'm totally doing this and not recording. I hate myself. Oh my God. Ugh. No, wait, I am recording. Never mind. Ignore that. I think I'm losing my mind. Next problem. Okay. So how many moles of H2SO4 are in 2.5 liters of 1.55 molar solution? I'm sorry, it's too late. I need to go to bed. Anyway, so let's check out what we're trying to find. We are looking for our moles of H2SO4, right? So we're solving for moles. We have volume and we have molarity, right? We have volume and we have molarity. So let's just go back really quick. We know that we're looking for moles, so we're going to use this equation here. Moles is equal to molarity times volume, right? So we're going to use this equation. Moles is equal to molarity times volume. And then we're simply just going to plug in the numbers like we were doing with the ideal gas law. It's so simple. So the molarity is 1.55. Right, that capital M represents molarity, and the volume is 2.5 liters. And we're obviously multiplying there, so we're just going to take 1.55 times 2.5, and our answer is going to be 3.8 moles. And now we know exactly how many particles of H2SO4, right, exactly how many molecules are in that particular solution. So we could do whatever calculation we needed to. Okay, nice and easy. Let's try another one. This one says calculate the moles. So again, here I want to use a different color. We want to know moles. So anytime we want to know moles and we have molarity, we're going to use that equation that moles is equal to the molarity times the volume. And it says calculate the moles of sodium chromate in 200 milliliters of a 0.75 molar solution. So for the volume, it's given to us in milliliters. Remember that it must be in liters, just like we had to do that for the gases, must be in liters. So what I'm going to do is divide by 1,000. That's how we convert things. That's how we convert milliliters to liters, is we divide by 1,000. So we're going to take 200 and divide by 1,000. So you're going to get 0.2 liters. Okay, and this, of course, is my volume. So I know my molarity is 0.75. I know that my volume is 0.2 liters. I just plug those into my equation. Okay, anytime we have two numbers written next to each other, we of course know that's multiplication. So we do 0.75 times 0.2, and our answer is 0.15 moles. Same thing we talked about for the ideal gas law. There is a minimum amount of work that you need to show. Just to clarify, the minimum amount of work that I want to see is that you need to just write out the numbers and then, of course, the answer. Okay, so that's the minimum amount of work for full credit. So I'm just going to say minimum work for full credit. That's all you absolutely have to show, is just the numbers plugged into the equation. Sometimes we like to write down more stuff, but you don't have to if you can get away with it. All right, let's look at another example. All right, how many grams of ammonium sulfate are required to make 3.5 liters of 0.5 molar solution? So we're looking for grams. Now, if we go back and we look at our equations here, right, there's nowhere to put grams, but remember that we can, here with the moles of solute, convert from, or we can calculate from grams. So we can convert grams to get moles, okay? Or vice versa, we can convert, if we know the moles, then we can convert from grams. So here, if we want to find grams, then we're going to start by solving for moles, and then we'll convert it out to the gram using the molar mass. So this is a two-step problem. I'm just going to write 2 steps, right? First, we're going to find moles. Then we're going to convert to grams. Okay, so here we go. Let's do this. We know the volume and we know the molarity. So we're going to use the equation that moles is equal to molarity times volume. So we're going to do 0.5 times 3.5. So 0.5 times 3.5 is going to get us 1.75 moles. And then we just need to take that to grams. Now, what do we need to know to convert moles to grams? The molar mass, right? And in order to find the molar mass, we need to know the formula of the compound. So we're talking about ammonium sulfate. Remember that ammonium has, the symbol for ammonium is NH4. Sulfate is SO4. These are both polyatomic ions. So we're going to look at their charges on our list. Ammonium is +1. Sulfate is -2. So we do our crisscross rule. We're going to need 2 ammoniums, right? Then we are just going to go through and we're going to do our math, and we're going to calculate 2 nitrogens and 8 hydrogens and 1 sulfur and 4 oxygens. And I'm going to save us a little bit of time and tell you that 1 mole of ammonium sulfate is equal to 132.14 grams. Okay, so that's our molar mass. So we're going to take that 1.75 moles that we have there and then do a little mole problem that we should all be experts at by this point. And we're going to multiply by that conversion fact. We're going to put the 1 mole on the bottom, of course, so that the units cancel, and the 132.14 grams on the top. And then we just do a little bit of math. 1.75 times 132.14 divided by 1 gives us 231.25 grams. Okay, 231.25 grams. Easy, right? Simply plug and chug and then convert to grams as needed. Okay, final example for you this video. I want to know how many liters of 1.4 molar solution are needed if you want to extract 0.45 moles of the solute. So again, this is the kind of question like I've got solutions in the back of the chemical storage room. I need to know what volume, like how much do I need to pour into my graduated cylinder of a specific solution do I need in order to do a specific calculation. So very common question that we will have to solve for. So again, we're looking for liters. Remember that liters is the volume. So that's my unknown. And I know the molarity is 1.4 and I know the moles is 0.45. So let's go back and look at our equation here. We know that molarity is equal to moles over liters. So if we want to manipulate that ahead of time to find volume, we know that we're going to take the volume, set it equal to the moles divided by the molarity. Okay, so volume is equal to moles divided by molarity. Again, I'm trying to help you guys out and show you how to solve the equations before you plug in the numbers. I think that'll cause a little less hassle for this year. So volume is going to be equal to the moles. Whoa, I'm not sure what just happened there. That was weird. The moles divided by the molarity. Okay, so we're just going to plug in our numbers. Again, volume is going to be equal to 0.45 moles divided by 1.4 molarity. So you just plug that into your calculator, 0.45 moles divided by 1.4, and we get 0.32 liters. That's our answer. Nice and simple. Okay, very, very easy. So again, today what we were talking about was when we had liters of solution. The last couple of days we were dealing with liters of a gas. Now we're dealing with liters of solution. Just a heads up, next week we're going to put these all together. You're going to have all kinds of different problems and you have to pick the correct way to solve them. We've now got essentially 4 different ways to solve these problems, but don't worry, I'll review that with you next week. Okay, so now it's your turn. You have to complete the mole calculations number 5, which is all about solutions. That's posted on Google Classroom. There's just 5 problems for you to do, nice and basic, and then I will check your work to see how you're doing. Let me know if you have any questions.